Just to help us understand how we can do this kind of stuff, I'm going to simplify this concept and now showcase a simple way of how we can do a derivative of an image. Again, you've seen this already, just a del of the image itself. Now we're going to look at it with x, which basically means in a finite difference form, I'm going to look for a value x plus 1, which basically means in this one, index plus the next column, keep the y the same, and of course, I look for the original column x itself. And I just subtract that, that'll give me the difference. We have done this in the previous sub-lecture also. Let's just simplify this and look what we can actually do to extract basically this concept of derivative as a local product. Those of you remember from previous lessons, local product, dot product, inner product was something which was relevant in the concept of cross correlation. Here I've just simplified this by basically multiplying the first term with 1 and the second term with minus 1 to get rid of the plus sign here. Let's rearrange this whole term. So when rearranged, now we've moved the negative term in front and the positive term later. Of course, we can rewrite this form as a dot product of the minus and the 1 as a simple vector, and then of course the fx and fx plus 1y as the other one. So this dot product is basically now in essence how we could compute something like this. Now of course this is interesting because in simple terms sometimes I could replace this dot product in case of images with a cross correlation, because in essence that's what this process would be. So this should start telling us something. This, for example, could be my kernel and this is my input, right? So looking at that kind of way, we can now start thinking about how we can actually start doing similar types of processing. Now of course this is still a dot product. I'm simplifying this to kind of say this is cross correlation. We'll look at that in a bit.